A block of mass 2 kilograms is placed on the trolley of mass 5 kilograms moving horizontally. A force of 8 newtons is applied to the block which slides on the surface of the trolley. The frictional force between the trolley and the ground is 0. The trolley accelerates at a rate of 1 meter per second squared. What is the coefficient of dynamic friction between the block and the trolley? So it seems that this upper block is moving to the right, so the frictional force opposing motion, so it will be to the left. And we can consider Newton's second law with respect to this block, and the second Newton's law says that the vector sum of all forces is equal to ma, and definitely there are two additional forces, it's mg and normal reaction. But if we consider the second Newton's law in horizontal components or in horizontal projection, components of mg and n are zeros. So in horizontal directions there are only two forces, and let direction to the right be positive, so it becomes 8 minus F frictional is equal to ma. Mass of a block is 2 and some acceleration of the block. Notice that it's not 1, because 1 is acceleration of the trolley, and definitely it is not the same. Acceleration of the trolley is not equal to the acceleration of the block. But we know that frictional force is what? By definition it's mu normal multiplied by normal reaction, and normal reaction is just mg, because it's actually also the second Newton's law in vertical projection, but in vertical direction it's just n is balanced by mg, so n is mg, so it becomes mu multiplied by mass and multiplied by g. And you can see, since we don't know acceleration of the block, we cannot calculate mu from this equation, but definitely since it is given the acceleration of the trolley, we should consider also the second Newton's law with respect to the trolley. And notice that this force is applied to the block, not to the trolley. And if we consider the trolley, there are what forces? It will be a frictional force, because these forces, frictional forces, arise in pair. It's actually action-reaction pair. It's Newton's third law. Every action has equal and opposite reaction. So the frictional force which acts on the trolley, it will be of the same magnitude but in opposite direction the frictional force which acts on the block. Forces are equal in magnitude but in opposite direction, but they are applied to different objects. And if we consider trolley, it will be the only horizontal force, it's frictional. And again, the second Newton's law in horizontal projection, so there is only one horizontal force, and it's the resultant force, and it is equal to ma, mass. Since we consider the trolley, it's mass of a trolley, it's 5 multiplied by acceleration of the trolley, it's 1. 5 times 1, it's 1, but this is equal to this, so it becomes 2 mu g is equal to 5, and hence mu, it's the required coefficient of dynamic friction, dynamic because it is moving, it slides, and it becomes 5 over 2 g. 5 over 2 is 2.5, g it's approximately 10, so it's approximately 0.25. So it's C, and that's all for this question.